Only the general methods can be used to solve bigger matrices starting from 4 by 4 size. Check out how it is done here in Numerical Solutions to CE Problems. For bigger matrices, such as the one we would use in our example, can be solved in two ways. One is the general method, which is Laplace cofactor expansion. The second is Chio's pivotal condensation method. The procedure on these two methods starts with the reduction of the matrices a step at a time. For the 4 by 4 matrix, we are going to have these reduced to 3 by 3 matrices and then use Sarri's rule from that point. The general method is known as Laplace cofactor expansion. From its name, we are going to use the cofactor of a matrix in reducing it until it is small enough to use the shortcut methods. Laplace cofactor expansion is a long procedure, but a tip to reduce the steps is to look for elements valued as 0. In the example, there are elements A12 and A31. For A12, we can use the first row or the second column. On the other hand, we can use the third row or the first column for elements A31. For the first combination, we consider focusing on column 2. The first step is to place the alternating signs just to shorten the solution. This is done by starting with plus sign on A11. So a negative sign is on A12. Now going down, the sign for A22 is positive, then negative for A32, and another positive sign for A42. With the signs already properly placed, the reduced matrix is laid using the elements of column 2. The first term is with negative 0 as multiplier. The second term is plus 2 times the cofactor. The third term has minus negative 1 as multiplier. Then the last term is plus negative 1. Next is to complete the minors in the determinants. By covering the first row, the minors for the first term are then identified as negative 1, 3, negative 2, with 0, 1, and 3, then negative 2, 3, and 4. When the second row is covered, the following elements are to complete the second term's determinant matrix. The elements when the third row is covered are 3, 5, negative 1, another negative 1, 3, negative 2, then negative 2, 3, and 4. If the fourth row is covered, the remaining elements to complete the matrix determinant are shown as 3, 5, and negative 1, with another negative 1, 3, and negative 2, then 0, 1, and 3. When the series of solutions is completed with 3 by 3 matrices, we can use Sarri's rule to simplify each. Now take a look at the first term. With whichever result of the matrix, note that the scalar is 0, so the whole term will end up as 0. This is the result of the tip we used looking for 0 element. The next term has a multiplier of positive 2. Then we use Sarri's method in simplifying it. First is to mirror the first two columns, then mark the diagonals. The first is 3 times 1 times 4, which is 12. Then the next is 5 by 3 by negative 2, giving negative 30. Then the last diagonal is negative 1 times 0 times 3, which is 0. The anti-diagonals start with negative 2 times 1 times negative 1, which makes 2. The next is 3 by 3 by 3 to give 27. And the last has 4, 0, and 5, which when multiplied together results to 0. So collect all products with the scalar. That is 2 times the quantity of 12 minus 30 plus 0 minus the negatives of 2 plus 27 and 0. Simplified, the quantity becomes negative 47. So the second term is negative 94. The third term is done similarly. The scalars minus negative 1, then we use Sar's method for the determinant. The first main diagonal has 3, 3, and 4, with a product of 36. The second diagonal has 5 times negative 2 times negative 2, and that is 20. The last main diagonal is negative 1 by 3, giving 3. The anti-diagonals have negative 2 times 3 times negative 1, which is 6. The second anti-diagonal contains 3 times negative 2 times 3, giving negative 18. Then last is 4 times negative 1 times 5, which is negative 20. Simplify all the products as 36 plus 20 plus 3 minus 6 minus 18 minus 20, which is 91. Then 1 times 91 is 91. This is the third term. The last term has a scalar of negative 1. Using Sar's rule, the determinants are solved with the diagonals with 3 times 3 times 3, or 27. 5 times negative 2 times 0 as 0. Then negative 1 times negative 1 times 1 as 1. The anti-diagonals have 0, 3, and negative 1, which multiply as 0. Then 1 times negative 2 times 3, multiplied as negative 6. And 3 times negative 1 times 5 as negative 15. Place them all together in one quantity to have negative 1 times 27 plus 0 plus 1 minus 0 minus 6 minus 15. And these result to 49. So negative 1 times 49 is the fourth term, which is negative 49. With the terms already simplified, the determinant of A is then 0 minus 94 plus 91 minus 49, which gives negative 52. Let's also try looking for the determinant using row 1. The sign reversal using row 1 has positive for A11, then negative for A12, which flips again into positive for A13, then negative again for A14. Now using the elements in the first row as scalars, we can write down the reduced series as shown for determinant A. Fill out the determinants where the first term will be completed after covering the first column. With the second column covered, the elements for the determinant of the second term are negative 1, 3, and negative 2, then 0, 1, and 3, then negative 2, 3, and 4. Cover the third column to have the remaining elements for the third term. The minors for the fourth term is found by covering the fourth column. These are negative 1, 2, 3, 0, negative 1, 1, negative 2, negative 1, and 3. Having completed the reduced determinants in their 3 by 3 form, we use Sarri's rule for the first term. The diagonals have 2 times 1 times 4 as 8. The second diagonal has 3 times 3 times negative 1, which gives negative 9. Then last is negative 2 times negative 1 times 3, which gives 6. The anti-diagonals have negative 1 times negative 2, which results to 2. 3 by 3 by 2 gives 18. Then 4 times negative 1 times 3 also gives negative 12. Now the first term can be determined as 3 times the quantity of 8 minus 9 plus 6 minus 2 plus 18 minus 12. This is reduced as negative 3, making the first term equal to negative 9. No matter what the resulting determinant is for the second term, the multiplier is 0, which zeroes out everything. So we move on to the third term. It starts with positive 5 as a scalar, and the determinant can be solved as negative 1 times negative 1 times 4, giving 4. 2 times 3 times negative 2 gives negative 12. Then negative 2, 0, and negative 1 have a product of 0. The antidiagonals have negative 2, minus 1, minus 2, resulting to negative 4. Negative 1 times 3 times negative 1 combine to 3. Then 4 times 0 times 2 gives 0. So the third term has 5 of 4 minus 12 plus 0 minus negative 4 plus 3 plus 0. That is 5 times negative 7, which equals to negative 35. The fourth term has diagonals as negative 1 times negative 1 times 3, which is 3. The second diagonal has 2 times 1 times negative 2, and that equals to negative 4. Last diagonal has 3 times 0 times negative 1, which is 0. The negatives are computed as negative 2 times negative 1 times 3, which becomes 6. Next has negative 1 times negative 1, giving 1. Then last anti-diagonal has 3 times 0 times 2, which becomes 0. Now 3 minus 4 plus 0 minus 6 plus 1 plus 0 becomes negative 8. So the fourth term is negative 8. Determinant A is then simplified as negative 9 plus 0 minus 35 minus 8, which equal to negative 52, the same determinant of matrix A as computed earlier. Next is for us to prove that we can also use the other element. With element A31, we consider row 3. The sign reversal starts with positive on element A31, then negative on element A32, positive again on element A33, and another negative on element A34. Next is to place the scalars on each term. Then identify the minors. Cover the first column and have the remaining elements as minors for the first term. Now cover the second column and place the remaining elements into the second term. Also take note that the operation is minus and the scalar is negative 1. With the third column covered, the minors for the third term are 3, 0, negative 1, another negative 1, 2, and negative 2, then another negative 2, negative 1, and then 4. Cover the last column and have the remaining elements as minors for the fourth term. With all four terms of the reduced determinant already figured out, we can start with the shortcut method. In the first term, the scalar is 0, so everything will be computed as 0. We move to the second term. The sign reversal has negative and the scalar is -1. Then, the 3 by 3 matrix will be solved using Sar's rule. The first diagonal has 3 times 3 times 4, giving 36. Next has 5 times -2 times -2, giving 20. The last diagonal has -1 times -1 times 3, which makes 3. The anti-diagonals start with -2 times 3 times -1, which is 6. Next has 5 times -2 times -2, giving 20. Then -1 with -1 multiplied by 3 give 3. The second term is then computed as 1 multiplied by 36 plus 20 plus 3 minus the negatives of 6 minus 18 minus 20. This simplifies as 91, so the second term is 91. The third term has 1 as a scalar, and the diagonals contain the elements 3, 2, and 4 to have the product of 24. Next are 0, -2, and -2 multiplied as 0. Then -1 times -1 with another -1 to have -1. The negatives are computed as -2 times 2 times -1 to have 4. The second anti-diagonal has -1 with -2 times 3 to have 6. Then 4 times -1 times 0 is 0. Simplify the products and have 24 plus 0 minus 1 minus the quantity of 4 plus 6 plus 0. This is reduced to 1 times 13, or positive 13. The fourth term has a negative sign attached with 3 as a scalar. The determinant is computed as 3, 2, and 3 multiplied to 18. Then 0, 3, and -2 multiplied as 0. Then the last diagonal has 5 times -1 times -1 to make 5. The negatives have -2, 2, and 5 to have -20. Then the second product comes from -1 times 3 times 3, giving -9. The last has 3, -1, and 0, coming up as 0. So the fourth term has -3 times the quantity of 18 plus 0 plus 5 minus -20 minus 9 plus 0 simplified into -3 times 52, or that is -156. The determinant of A from these terms is taken from 0 plus 91 plus 13 minus 156, giving -52 just the same. Let's also check if taking the first column proves to have the same determinant. After the sign reversal, place all scalars into the series, showing 4 terms with 3 by 3 determinants. Cover the first row and get the minors for the first term. Move the covered column to the right and take the remaining elements as the second term elements. By covering the third row, we take the remaining elements as minors for the third term. The fourth term determinant can be solved from the minors which remain after we cover the fourth row. With the series already completed, Use Sarah's rule to identify the determinants of the 3 by 3 matrices. The first small determinant can be solved from 2 by 1 by 4, giving 8. 3 by 3 by -1, which is -9. Then -2 by -1 by 3, resulting to 6. The negatives have -1, 1, and -2 to have 2. 3, 3, and 2 to have 18. Then 4, -1, and 3 to give -12. The first term is then thrice of 8 minus 9 plus 6 minus the negative comprising 2 plus 18 minus 12. Then that would be 3 times -3, or that is -9. The second term has a simplified +1 scalar, then the diagonals contain 0, 1, and 4, resulting to 0. 5, 3, and -1 have a product of -15. -1 with -1 and 3 give 3. The negatives have -1, 1, and -1 to give 1. 3, 3, and 0 to have 0. Then 4 times -1 times 5 to have -20. The second term is computed from 0, minus 15 plus 3 minus 1 plus 0 minus 20, which are simplified as 1 times 7, or that is 7. With a 0 scalar at the third term, the whole term becomes 0. The solution to the fourth term starts with 0, 3, and 3 as 0. Next has 5 times -2 and -1, giving 10. Then -1 times 2 times 1, which results to -2. Then the negatives for this term start with -1 times 3 times -1 to have 3. Then 1 times -2 times 0 is 0. And 3, 2, and 5 are multiplied into 30. The fourth term is then twice of 0 plus 10 minus 2 minus 3 plus 0 plus 30. That is twice of -25 or -50. Now we can take the determinant of the matrix as -9 plus 7 minus 50, or that is -52. The other method in sorting out the determinant of a bigger matrix is through Chio's pivotal condensation. In this method, it is mandatory that the pivot element be valued at +1. The sample matrix has element A33 equal to +1. So we cover the row and column of this element. Now make a matrix with the remaining elements. The first column has 3, -1, and -2. The second column has 0, 2, and -1. Then the third column contains -1, -2, and 4. The next step is to subtract pivot elements. How do we look for them? Say we are to subtract the pivots on element A11. The vertical pivot element is 0, and the horizontal pivot element is 5. So we subtract 0 times 5. Element 21 is subtracted by 0 times 3. And element 31 is subtracted by 0 times 3. Do the same procedure with the second column. A12 is subtracted by -1 times 5. Element 22 is subtracted by -1 times 3. Then element 23 is subtracted by -1 times 3. The third column on the first row be subtracted by 3 times 5. The second row is subtracted by 3 times 3. And the last is subtracted by 3 times 3. simplify all 9 elements and get a 3 by 3 matrix with the following elements. Since we already have a 3 by 3 matrix, we can easily take the determinant through Sar's rule. Diagonals start with 3, 5, and -5, resulting to -75. 5, -11, and -2 give 110. -16 times -1 times 2 result to 32. Next has -2 times 5 times -16 giving 160. Then 2 times -11 times 3 which becomes -66. Last diagonal has -5, -1, and 5 giving 25. So the determinant of matrix A is simplified as -75 plus 110 plus 32 minus the quantity of 160 minus 66 plus 25. And this result to -52.